So now let's turn on the video. So you know that our focus is your face. We don't care what's going on in the background. So don't be shy. And wow, stadium. Oh, that's how nice. Yeah. Okay, let me turn off some of my apps. Let's see. So just a few things about the tech. You all can hear me well, right? You can see me well? Great. What else? Because there might be some unforeseeable technical issues, it's just unpredictable. I'm going to select a co-host just in case if I'm off, so that everybody can stay put. And who would like to volunteer? If you feel confident about Zoom, feel free, please. Any volunteer? Raise your hand. Elaine? Okay. Great. Let me make you a co-host. And although I don't know how to do that, maybe on the name. Yeah, I guess. So the name more, make co-host. Okay, I just did that. Please confirm that you can see that your role has changed.
Do I need to confirm anything or after you?
I don't know.
It
looks like it's confirmed. Only I have to confirm that. And if you look at the participant list, you see your name, you might see that you're the co-host.
Oh, I see.
Guest. Okay,
I got you.
Thank you. Thank you for your service. And what else? Names, everybody's name. Milan, I see two Milan. Which one is you? Let's see. What else? So just check in a few things before we start. Co-host here. I think we're good. Okay, how many? I think I'm missing one person, but let's get started. All right, I think we're a small class. If you don't have noisy, events going on in our background, feel free to unmute yourself. I'd like for everybody to be able to, chip in and start discussion anytime that's suitable. So please unmute yourself unless you have a noisy background. Let's see. All right, so how's everybody?
Doing good.
Good. Just beginning of the semester. All right, good spirit. Anyway, I think we're waiting on a storm to come by, or hurricane to come by. I hope that we won't be disrupted. Okay, so welcome to this course. I'm excited to start this. This is the first time this course is offered. I'm glad to be your professor, and half of the class know me, so I'll just briefly introduce myself. And I said a few things in the welcome video. Have you been able to watch the welcome video?
Yeah.
You can watch them, right? They are on. There's some technical issues with Microsoft Stream, but I hope that you're able to navigate that. My name is Xiao. It's hard to pronounce, but it's just simply Xiao, like shout, something like that. So, and or feel free to call me Xiao or Professor Ma or Dr. Ma. Originally from China, have been in the US for 10, 12 years, I think. Been to various places in the East, in the Midwest, North, in the West, and in the South. I've even been to Mexico for some visa issues. Anyway, some of you might be being through the same experience. So it's a fun place. I would say except Donald Trump, everything is fun. So, but he's fun to watch.
Yeah.
Not a fun to be a president, to be honest. But anyway, I hope, it's going to be over in a matter of a few months. So then we can start normal life again. Anyway, so this course, so how are we going to spend the time here? I'll mostly, most of the information are outlined in the slides. So I'll turn on my slides. I'll share the screen with you. But this is the first time I do that. I don't know if I will be able to see your faces when I do those because my screen is being shared. But we'll see. I'll try to navigate. During the process, we'll do a few breakout rooms just to save time and let everybody know each other in small groups. And eventually we will start forming teams because that will be a good environment for people to sort of converge together about the vocabularies, the techniques, different kinds, different names and different components, and hopefully by the end of the semester we all have a unified sort of a dialogue and using consistent terminologies and making sure that we're referring to the same thing when we say that, and then that will improve the understanding and interpretations as we go through the course and advance to more complex models. Those terms tend to be complex. So I just want to, better prepare everybody. And in Teams project, I think that is a good environment. Beginning homework 3, maybe we'll do team homeworks. First and second homework will be individual based, just to set up the individual independent part of the learning. Let's see. So let me just begin the slides.
Excuse me, Professor.
Yeah.
Can you hear me?
Yes, I can hear you.
I do have a question. Yes. My question is, are all of these Zoom meetings recorded?
Yes, it's being recorded.
Right.
So after the class, I will do some editing, maybe beginning, and I'll trim the beginning, and I'll post it on. I think I'll post it on Zoom. Not Zoom. I mean, I'll post it on Microsoft Stream, so that only you guys can see them. Outside people cannot. Is that good? Great.
Yes, thank you.
So the first time I'm recording for a long session, I'm imagining this is over an hour, definitely. I'll see. I hope there's no technical issues. I'm pretty good with videos and those kind of things, so I hope there won't be a problem. I'll do my best. Let's see. Let me start my slides. And so I'm going to start the slide 0. You don't have to turn it on because you'll see my screen, but feel free to turn on the slides on your computer as well. And I'll share the screen. Let's see. Share screen. So I have shared my screen. Can you see it? Great.
Yeah.
When you see the screen, will you also see the the tiles, the mugshots of 6, including me? Do you also see them, or just only myself see it? Do you see people's faces?
We can see you. We can see everyone.
You can see everyone in your Zoom window.
Yeah.
That's what you mean. Okay, you don't see another
Right.
window. You don't see my Zoom, right? You only see your own Zoom and the screen. Great.
Good.
I just don't want to create confusions because I'm going to rearrange some of the tiles here. Okay, anyway, let me turn on the slideshow then. Okay. This. Now, do you see that? Great.
Yes.
Great. Okay. Great. All right. So when I'm talking, if you have a question anytime, make yourself heard, unmute yourself before you talk. Okay. So I hope you had a chance to review the slides, but it's fine if you haven't. Here's the agenda of the first slides. The first slide is mostly overviews a course and overviews the basic terminologies and set up the dialogue background and the context. We'll spend a few minutes to meet each other and to know each other. And I'll talk about the format of the class. This is a new kind of class. It's in the history of my teaching, it's very new. So I'm making experiments and I'm making mistakes, and hopefully it's not going to be huge mistakes. And I'll tell you a little bit about what to expect from this course. Then I'll talk about my expectations from you. And on the right, you will see the basic terminologies. These are what we're talking about. I'm talking about those terminologies. I'm talking about, the context and technologies with these technologies in mind. So, I'm pretty sure you're all familiar with what I'm talking about. Otherwise, you won't be here. So AI, as you know, AI is a buzzword it has been that for close to 6-7 years, and as time goes on it becomes more popular, and then the job market picks up, the tech industry picks up. So without reservation, I would say AI, to me at least, AI is the sexiest job, the sexiest career at this time. Every person has a different definition of what's sexy, but to me this is very sexy in terms of serious businesses. Various reports have confirmed that in the academic world, AI is predominantly pushed by the tech companies, and the tech companies is supported by the academic research effort across the higher education institutions, mostly those with engineering and computer science majors. A number of papers published in tech conferences and papers focused on, prominent areas of computer science and machine learning, artificial intelligence. They have received exponential growth in terms of number of papers submitted, number of papers accepted, and so on. And the US and China mostly play big roles in this domain. Various reports, they all point to the same trend. So the trend is, is undismissible. It's quite clear. Being part of it, I think you can benefit your career and your future. Okay, now let's talk a little bit about yourself and know a little bit about each other. I'm going to put you into breakout rooms. I'll do 4 breakout rooms. This is the first time I do it. Let me, hopefully I don't mess it up. With screen sharing, can I do that? I don't know. Maybe I have to exit the screen share. So let me do that. Stop share. And let me put you guys into breakout rooms. And hopefully you turn on your video, and also for those who haven't, turn on your video and turn on your voice. And in groups of 5 mostly, groups of 5. Sometimes you may have group of 4. You know, mainly talk about you know, who are you, what's your background, fun fact about you, what's your hobby, but most importantly, why are you fascinated by AI, machine learning? What are you here for? What are you here to learn in this course? You know, feel free to share your own story, and then we'll converge after 5 minutes. So let me set up the breakout rooms. When you see the prompt on the window saying, you know, enter the room, please go ahead. And before the breakout room is going to end, there will be a countdown. Don't be panicked when you see the countdown. You won't be kicked out of the meeting. You will simply be rejoined into the main room. All right. And I will be jumping across the breakout rooms. So let's see. I'm going to randomly assign, but in the meantime, I'll try to know each other. I will jump across the windows, and as the semester goes forward, hopefully there will be a sort of more natural groups will form, and then I will configure the form specifically. All right, let me open the rooms option. Let's see, move on. So I think I will move you to the breakout room automatically, so you don't have to click anything. So I'll set 5 minutes as the timer. Okay, let's go.
Hey everyone.
Hello.
Hi.
Hey, just pretend I'm not here.
All right. Okay, I'll start. Hello everyone. My name is Li Hong Li, and I'm from China too. And this is my second year of my master degree, and I'm majoring in business analytics. And I'm a 2-year-old boy, a mom too. And nice to meet you guys.
Hi. Can you hear me?
Yeah.
Yeah.
Yeah. Hi. My name is Tan, and I'm also from China. And this is my second semester here at UH. And I'm also from the BZAN program. So fun fact about me, I like cooking, and especially baking. And I also like badminton. I did this a lot during the quarantine, and I have a 1-year-old son. So I'm very happy to be here.
Hi everyone, my name is Imad. I'm from India. This is my second semester at the University of Houston. I'm studying BZAN, Master of Science in Business Analytics. It's really great to meet you all, and I hope we have fun together.
I really want to do those works with like with a AI or just with some software, like to cut those. Like I have to read files of papers. I want to like make the job easier. That's why I want to learn something about coding and also AI.
Oh, hey everybody, I'm Justin Braden. I'm in the Master's in Business Analytics, Data Analytics program, and this is pretty much my last year. AI is pretty fascinating. I don't know much about it, so I kind of got to work on that. That's why I'm here. But it's a really fascinating topic, and kind of just to piggyback on what Sieben was saying there, and Soria about how Tesla is using it,
so far. And just being in the statistics and all the business analytics classes I've taken so far, like I'm really enjoying that. So I'm thinking about pivoting.
Just pretend I'm not here.
So that's why. But I'm loving everything that I'm doing so far. So I'm just, why not get a certificate while I'm at it?
And what about you, Johnny? Did you like, are you like working in something related to statistics or analytics?
Well, I actually used to work in the investment department in a retail company, but mostly, real estate, stuff like that, and some stocks. So for me, I guess machine learning, artificial intelligence is brand new for me. I'm really excited, but I'm also not quite sure what I'm gonna learn. So
I really
see.
feel like it's such a buzzword. Everyone just throws machine learning and AI around. It's in commercials and everything, and it's like I don't like how it's like a buzzword at all. Like I remember there was this Microsoft Surface commercial. They used to just say AI, and it's like some magical thing, I hate it.
Right.
It's cringy for me.
Exactly.
How about you? Oh, we're gonna.
All right. Well, nice to meet you guys.
Nice to meet you.
Very true.
All right, so time is almost up. I think this is the main room, right? Yes. And we'll just wait for the rest of the rooms. I hope you had fun. You knew a few more of your classmates. And by the way, Dream1, do you prefer Johnny? Is that your preference?
Yeah, you can call me Johnny.
Great. And you worked in the tech company?
No, not really. I'm not working now. So,
okay. You used to work in a...
Not a tech company, it's a retail company.
Oh, retail, sorry.
Yeah.
Overheard it. But, all right. So what was fun about your group? What's the most fun thing that's mentioned in your group?
It's about the topic about machine learning, artificial intelligence. It's like everybody is learning AI and ML, so it's like the hottest topic right now. Yeah.
So just the term of AI is enough to keep you pumped,
Right.
It's like 10 cups of coffee, and five cans of Monster.
Yeah, just drink it first before you know what's in it.
Yeah. So there's a tension between how popular the term is and what people really know about it, right?
Mm-hmm.
It feels like everybody knows what they're talking about, but I'll guarantee you, few people know. Few people really know. It's just it's a convenient way to, put yourself up so that other people know that, you know, at least you know something.
Like,
but I think you guys are here really to be confident about what this is. So next time when you talk about this, especially to a company or to a potential employer, you are going to be accountable for what you say, because they are going to hold you accountable, you know. So, and this is the purpose of this course. My mission is to unwrap, you know, to unbox the black box. So I'll talk about that. So let me return to the slides. I'll share my screen again. You can see it?
Mm-hmm.
Great. All right. So just the AI. Okay, nothing else. So we'll talk about AI and talk about machine learning. I'll talk a little about the format of the classroom. I think many other classes might have the similar structure. It's flipped classroom. You know, by now I think you're quite familiar with what that means. 10 years ago, when the term first appeared, it kind of keep people, you know, scrambled. But because now video technologies are more easily available, and even I can do a lot of videos, and I can record the screen. I can do demonstrations. So a lot of content that has to be said in class and demonstrated inside the class can be prepared beforehand. So the benefit of that would be that you can start the learning much earlier. You can be kept motivated by, you know, pieces of time woven together. It doesn't have to happen in a 3-hour time, you know, that makes people tired. And maybe, you know, 1/3 of that time is spent, you know, dozing off. But, you know, we don't have to do that, right? So, but with that, there's more expectation from the student, because, you know, come prepared for the class, watch the videos that are specified, hopefully browse the book chapters that's relevant. Best if you read them and try to digest them, and then come to class with questions and discussions. So that would be the best case scenario, and that's my hope for everybody here. The benefit is that we can spend less time here inside the class. You know, we don't have to use 3 hours. Normally 3 hours are not enough even. So with the face-to-face class, you know, as you remember, 3 hours might not be even enough, and we need the break time. We need to take some rest. And we need to do different activities in the middle, just to keep everybody alert and awake, you know. But now we don't have to. But with online teaching, you know, from my side, it's actually quite challenging. I have a lot of competitors in terms of online teaching. So what do I mean by that? You guys have you have YouTube, you have Netflix in your home, on your TV. I can't compete with that. You turn on Netflix and put on a movie or put on a show, your attention gets stolen away. So I can't compete with that. I definitely will lose to your dog if you have a dog. You know, I can't hold your attention. I may be able to win over your cat, because cat likes to stay away from, you know. So I like cats because of that. But definitely, I can't win your girlfriend if you have a girlfriend at home, you know, or your boyfriend. But if you're married, I may be able to win your wife, because this course is sexy, you know. And maybe if you have a husband, I may be able to win over your husband, but I'm not sure. Let's see how that goes. Okay, so attention, right? I like to hold your attention and keep you motivated and effective during the time that we have class. So my goal is to keep every class at 1/2 hour from 6 to 7:30, just because you spend a lot of time outside the class watching the videos, doing the learning yourself. Inside the class, we can make it more effective. And I can always allocate the rest of the time for questions, so that you don't have to find another time to do a video chat with me to solve your problem. So come to the class with questions, with problems, and with discussions. We can spend the time more meaningfully. Does that sound good? Great. As always, make yourself heard anytime that you have question inside the during the process. Okay. Now, I mentioned about the welcome video. Hopefully everybody, most of you have watched it. And I will require 2 textbooks. One is the Python machine learning. This book is very good. It's more than what we need in a class, but I hope that as a takeaway from this book, it's beyond. So it will help you continue the journey after this course is over. It helps you better able to pick up the rest of the chapters in the book. The book even touches or goes deeper into deep learning. That is the topic that would be the skills of a senior data scientist without experience, of course. But then what you need to do is to accumulate industry experiences. So that will be, continuous outside the textbook. I will refer to this textbook in various places, in homework, in the slides, or in the video. So I will refer to it as PML. Whenever I say PML, or whenever you see PML as Python machine learning, that's this book. Another book, which is more theoretical, talks you use very good language to talk about these complex concepts in common languages. It's the data discovering knowledge in data. I've been using this book for quite a few years. I like this book, and the feedback has been good. So I will refer to this book as DKD. Whenever you see DKD, I mean this book. Beyond these 2 textbooks, then if you have more time, if you have more eager to learn, read anything that interests you about machine learning and AI. If you're really interested in one paper, but you have trouble understanding some of them, let me know. I may be able to help you. That laughter is the best doctor, but interest is the best teacher. So you have a better teacher than me. So why not use it, right? Any questions so far? Good. Let me know if anytime you have a question. So are we good on time? Your expectation from this course. So AI and machine learning is a black box. Even the experts will say that. It's a black box. My mission here is to help you unbox the black box. It's not enough to simply learn how to use it. Especially in the tech and in the computing world, it helps a lot. It perhaps is the most helpful if you learn and eventually know how to build something from scratch. So that is the process that I will take you through this course. Based on a few of the very classic but very popular models, I will unbox the inner workings of those algorithms. I will talk about mostly intuitively, why do they do this? I can't go too deep into the theory, but I'll provide the rationale of why this makes sense, why this will enable the computer to learn, but then most importantly, how to build it from scratch, how to connect your code with the, make the formula and the matrix calculation. Why is this? And to help you better see that you can do it. If you spend the time, you can do it. The link is not so far off. It's not so difficult to understand. You simply need a few pointers, and that's my job. Strong, you may have heard about strong AI, weak AI, right? Do you know the differences? Maybe not. AI, all AI are fascinating. So whatever AI, right? Anyway, strong versus AI. Strong AI would be those autonomous AI technologies. Those AIs that can guide themselves, and even sometimes people understand it as self-consciousness. When machines have self-consciousness, knows its own, has its self-awareness, that's when the AI has reached a strong AI level. I don't think we have truly strong AI yet, or really competent AI yet. We have a few examples, but only a few rare examples. So don't be misled by the names. Weak AI doesn't mean it's really weak. It's really what's transforming the life and how we do businesses. The strength of, or the development of weak AI is mostly because of the computing resources and computing powers that have progressed in recent years, and also because of the research, all those research papers. Feel free to read this paper on your own. This is optional reading, but it unfolds the process, or it unfolds some stories, some of the context and backgrounds and successes of weak AI in the healthcare analytics context. As you know, healthcare analytics will be big and huge in Houston. In Houston, we have demand, but we haven't been able to satisfy the demand yet, mostly because the two universities in Houston haven't done much here yet. Now I'm going to try to do something significant in the next 10 years together with my colleagues. We'll do research and we'll focus on collaborating with healthcare providers to try to better leverage AI in healthcare clinics and healthcare operations. Rice doesn't have a big program in computer science or healthcare programs, so the future is bright. In healthcare, talking about healthcare, I have a good comic here that hope you enjoy it. So doctors, some of doctors may be out of job. I don't know. I don't think so. I don't think so soon, but they can definitely outsource some of their job to advanced AIs once they are trained adequately. AIs can do some things better than humans, better than human experts. The key is how to understand those programs, how to understand those algorithms, the limitations and the pros and cons of different algorithms, how to match proper data with proper algorithms. Sometimes you need to tweak the algorithm to make it work in the particular context. But hopefully this course will help you get to a level where you can tweak the models. So that's beyond the level of grabbing a software and run the analysis. That's not enough. For business analytics, for data analytics, and for advanced data science, you need to be able to unpack the model and tweak things to achieve a higher level of accuracy or a higher level of performance. All right, for weak AI, it's the focus of this course. We will not focus on strong AI because we simply don't have many examples. For weak AI, we have so many examples. Hey Siri, Hey Google, Alexa, and I don't know if you know about the Target story. Target knows when you're pregnant before your dad knows, and they tell your dad that you're pregnant. That's kind of the story behind it. But now, so that was 10 years ago, and now Google knows what you are thinking about before you realize it. So that's the life that we are living in, the environment that we're living in, and perhaps in 10 years, Elon Musk knows how to transform human before we even know what our kids will look like. So I'm very looking forward to that to that time. Let's see. So basically, to be able to unpack the black box, you'll be prepared to go through some basic linear algebra math formula and be able to transform that or translate that into the code level, how to implement those in Python, mostly using pandas and NumPy. But you have structured examples to show you how to do that. You have structured homeworks to guide you through the steps. Afterwards, you put all your solutions together. It's a working model. So you will build things from scratch, but you will be in a guided path toward completion. I don't think any of you will have a problem. You simply, some of you may feel it's so easy. Some of you may feel it's a little bit challenging. As long as you put in the effort and time, when you have trouble, let me know. I help you go through those. Eventually, everybody will go there. Will be there. Trust me. We'll be using Python as the programming environment. Needless to say, that is the most popular data science programming language. You will not have to. Let me use a highlighter. Wait, no, sorry, not highlighter. Laser point. You will not need to memorize the formula. You can prepare all kinds of cheat sheet. I prepare some cheat sheet for you. Those are mostly the process maps to help you understand what to do first and what to do next. And with notations in terms of matrix computation and the code level implementation. But feel free to modify those. Download the picture and do modifications. You don't need to memorize the formula, but it's important to understand what they mean and be able to interpret and even explain to another person, what does it do mostly here? And why is the case that when the parameters move this way, the model is getting better or worse? So that's the expectation. I have prepared multimedia resources and materials to help you go through the exercises, the homeworks. For most of the homeworks, there are homework assistance videos. I encourage you to delay watching them. Try to attempt to solve those problems by yourself. You have the resources as your backup material or backup resource. You can get to them anytime. They're all on YouTube. But before you look at those, test yourself. See if you can, implement them by yourself. Any questions? No? Good. Let's see. With the video tutorial, sometimes I have PDF tutorials as well. Oh, by the way, let me ask you: have you installed Python yet? Most of you. If you have gone through another class, then you don't need to. Simply, maybe my suggestion is, it's been half a year, it's been 5 months or more than 5 months. It's better to update those packages. You know how to update the package in pip. You can pip install package -- upgrade. you can upgrade every major packages, including pandas. You don't need to update NumPy, I believe, but you just check. And scikit-learn, matplotlib, and Seaborn, those major packages. Question? No? It's my own voice? Sorry. Anyway, inside the class, I will explain some of the critical steps. So I will re-emphasize some of the materials that might be harder to figure out yourself, or simply, collect questions and answer those questions. Exams will be open book. So, as I said, there's no need to memorize those formula. You simply need to be able to complete the processes on your own doing the homeworks. Once you complete them once, it's better to familiar with yourself, once in a while, and complete it one more time or review the material. I think by then you will be ready for the exam. The exam will not be too much over the homework. I will simply change the context, change the variables, or maybe adding a few different things. But the rationale behind the homework, behind the exam questions will be similar to the homeworks. Let's see. Time check. So it's 50 minutes. Great. Let's see. All right, so you can review the slides. Basically, that's what one more thing. Start homework as soon as you can. I provide a map, a timeline map about the course path, right? So I lay out the videos you need to watch, the slides you want to prepare for each class or each module, basically, and what modules is each class going to deal with, and also the time period for which the homeworks or some of the test materials are relevant, and on the side in colors. So I suggest that you start homeworks as soon as the relevant chapter begins, because those questions follow a sort of a natural sequence of the learning path. After next week's class, you can start doing the homework 1, and you can finish quite a few conceptual questions and some of the hands-on questions after the next class. And then following the class after next week, you can finish the rest of the homework. So, you can build the homework over time. Don't be a last minute starter. That will, that won't work well for you. Starting it as soon as possible will work best for you. That's my belief. You have all the resources to help you. Okay, I think that is pretty much it for the overview. Now, I think we're good on time. My plan would be to, we can take a short break, and I'm going to talk a few things about the conceptual side, an overview of the machine learning and artificial intelligence using the first slides, the slides 1 deck. And I will finish before we start the data science warm-ups. So today is mostly about conceptual terminologies. Sounds good? So we can take a short break. Well, we don't have to. I don't have to. I'll keep the screen on. Feel free to unmute yourself, or feel free to mute yourself, and feel free to turn off your video. Let's take a break of 5 minutes. The recording will be on, but we'll take a break of 5 minutes and come back roughly at 6:57 or something like before 7. Good? Right? Yeah, let's take a break. Okay, I hope everybody is back. Can you hear me? Great. So, all right. So let me put on the slides. This is slides with number 1. And just want to remind you, all the Python implementations or demonstrations inside the slides, the codes and Jupyter Notebook will be provided on Blackboard. Let's see. Okay. Shall I start? Yeah? Ready?
Ready.
So great, thanks.
Ready.
Introduction to machine learning. If you have taken the advanced programming course, it will be familiar with this. I'm mostly talking about the background and the process model. So the kind of machine learning that I'll talk about in this class is mostly on the software side. We will not talk about robotics. We will not talk about the hardware side. We're only talking about how to crunch the data and how to better deal with this data, you know. And strong versus weak AI. I don't know if this is the first time you hear about it. I think let's do a little bit of a discussion. Let's do the breakout room again, since we're talking about a few things. We might have some thoughts. Let me stop this screen share first, and I will use the same breakout rooms as we did before just now, and we'll do another 5 minutes. Just just talk about your thoughts. You might have some new thoughts in the past in the past hour, in the previous hour. Just share with your classmates. All right. So let's get started with the rooms. Check the option. Okay. Hey, don't know where to start? All right, so let me ask you, who has smart homes in your home? Who has Alexa? Who has Google Home, Google Hub?
I have Alexa.
You have Alexa?
I'm ready to use it.
How long have you been using it?
I purchased it. I think it's maybe 2 years or 3 years ago. I forgot. But I'm rarely to use it because I noticed like sometimes I ask Alexa to play some music, but it only can play Amazon Music or something, and I have to pay for the subscription. Yeah, the monthly, the fees for that. So I think it's So I'd rather use YouTube to play some music or videos.
Mm-hmm. Yeah. Who else has Alexa?
Alexa is from Amazon.
Yeah.
Yeah.
I use Google Assistant. If that makes sense.
On your phone?
Yes, on my phone.
Yeah.
Do you have Can
Lily,
you hear me?
your voice is a little bit churned.
Yeah.
So maybe a network issue.
I do have Alexa at home, and I use it every day.
It's hard to hear you.
Yes.
No, it's hard to hear. Anyway, and so no, don't be sorry. You know, maybe a network issue. And Winnie, do you use any smart home?
It's fine. It's okay. No, actually.
No, that's fine. Yeah, I haven't been using it. But I was, let's see. So I recently moved and I changed a electricity company, and as part of their policy, they gave me a Google Hub for free. So that's how I started using it. You know, because I really don't.
I use Alexa every day. I sometimes just speak with Alexa.
Great. So it's helpful to you on a daily basis. Can you hear me? Well, network issue again. But anyway, so I feel like these assistants, they are interesting to try, but you never pass that, you know, momentum where it's really great. It's really helpful. You're reluctant to change your habit. You know, it's hard. Changing habit is not an easy thing. If there's not really, if not everything is working together, there's really no point to change. And you know, speaking requires energy. You have to speak to somebody who 50% of the times don't understand you. Then you have to repeat and repeat. Then, you know, there's a countdown, but we can, you know, remain in the room until system kicks out of the breakout room.
Would you have seen the advertisement, Lisa? So it's similar like the Siri, like the iPhone Siri.
Not well. The way you interact with them is similar. You know, you Google. I don't know Amazon, Alexa, but anyway. And I hope you had fun. I was in one of the group where we were talking about the different kinds of smart home assistants. You know, it's they are good, but you never feel that you can't live without them. You know, it's different from a phone. You can't live without a phone, but you can't live without those assistants, Google Assistant, Alexa, and you know, even Siri. You can't live without them unless you work on a special kind of job, and your hands are not free, your eyes are not free all the time. Then maybe those assistants will be helpful, but for most people, it's not the case. So I don't know what the other groups may have been talking about.
We came up with a question. We were wondering, is autonomous driving strong or weak AI? Because strong AI means no human intervention. So level 5 autonomous driving would be that, but at the same time, it's not conscious at all. So
yeah, interesting. It's interesting. So selfless driving, autonomous driving, or autonomous car, self-driving car. Do you think it's a weak or strong AI?
I think it's a strong AI because
I think
after the initial stage of training, it should automatically be able to take decisions based on its previous inputs and previous data. So I think that comes under the strong AI.
Okay, that's your perspective. Is there a different opinion, or do you agree? So I think everybody has a definition, and it's fine because the discipline is evolving. To me, what is weak AI? What qualifies as weak AI but doesn't qualify as strong AI is that if the technology is able to do something that only human used to do well, but the technology is not able to do anything beyond that, that's already good. Oh, let's acknowledge that. But if the technology cannot do anything materially beyond what it can do that is better than human, or do as good as well as human, I consider that as a weak AI. With strong AI, that's self-conscious, programs, and although we prevent the machines to have self-consciousness, that's something to be debated. But anyway, so with that rubric, I would consider still Tesla and self-driving cars to be weak AI. But I may be wrong. Who knows? But the thing is that many people don't think about it. AI is AI. It's fascinating. The weak versus strong AI doesn't make sense. But from an academic point of view, this is what they agreed. Not about specific technologies, but the boundary of strong versus AI, it's quite clear in the academic discussions. So, any else? It's interesting.
Excuse me, and what could it be an example of a strong AI?
It's a really good question. Let's see. Let's see. The best example I can think of maybe AlphaGo, but that's limited to a very specific game with clear boundaries and clear rules. AlphaGo is the Google development in playing the game Go, which is the black and white dots on the board, and try to occupy the territories of the board, and try to beat the opponent. It's able to learn from itself, so there's a level of self-consciousness and self-learning going on. But I don't know if that really qualifies as strong AI.
I wanted to add to my question. So there's like level 5 autonomous driving where you just sit in there. I don't know if you've heard of level 5 autonomous driving. Would that be considered strong AI if there's no input from the driver?
Is that a real thing yet?
It's not a real thing yet.
Yeah, maybe if once it's real, it could we can definitely consider that part of that, crossing that boundary. But I just think that being conscious about the boundaries of different levels of AI will help you make the conversation more interesting with others. There's no definite things to be said here. The whole thing is evolving, and I'm not even expert in strong AI, so I'm on the application side. But if you're interested, the next time you bump into a computer scientist who is working on strong AI, definitely ask a question. Can you give a real life example of strong AI? And I'll be interesting to see what he says. So that's it. Any other interesting things to talk about? No, we can move on. Yeah. So I'm not sharing the screen yet. Let's do that. All right, so yeah, so we'll focus on weak AI mostly. Similar terms in business to the concept of business analytics, data mining, text mining, big data, data analytics, business analytics, neural network, and AI, natural language processing. Interesting. I will try to, I think for the third component of this course, I will try to focus on some of the natural language processing. So for the third homework, maybe the fourth, I think the fourth homework, you'll deal with, analyzing the texts, which is quite interesting. A lot going on, not less than the numeric numbers, but it's a different kind of skill. Sometimes clustering analysis is unsupervised learning. Terms in other disciplines that are similar to what we're talking about. The terms that I mentioned just now mostly are familiar to business analytics professionals, but in computing, they mostly talk about computer vision, voice recognition, natural language understanding, and other signal processing kind of analysis. So their problems are very specific, and that drives a difference with the process model I'll talk about. Let's see. Okay, a trichotomy of the machine learning tasks or machine learning methods, basic three different kinds, supervised versus unsupervised learning. You may be familiar. And there's a third kind of learning, machine learning, which is reinforcement learning. This course will focus on the first two. And we'll emphasize, 60% of the course is the first type of learning, and maybe 40% or 30% of the course is about the second kind of learning. Because in the industry level, still, I think it's the supervised learning is having the firmest ground in terms of application and solving problems. And so this graph is from this book, PML. And some examples of these, of supervised learning include classification. And those tasks, those estimation tasks are talked about in the other book, DKD. Classification is to try to predict the class label of an observation based on the input variables, and to classify the case into one of the few discrete labels, churn versus no churn, default versus no default, and sometimes multiple multi-class categorical variables, which are the target variable. Also, estimations or predictions of a continuous variable, for instance, house prices. So these would be the under the supervised learning category. The difference between supervised and unsupervised, whether or not there is labeled data to provide feedback to train the model, whether or not the model is being trained in a particular direction to perform the task. Unsupervised learning is trying to find pattern which you may not be aware of. So, which means try to let the pattern emerge from the data by using different techniques, by trying to group things together if they are similar. Clustering would be one of these models. Segmentation is another name for that. Classic examples: the Nielsen, one of the Nielsen branch, Claridis, they profile viewers demographics in close to 100 different profile personalities, so that they can match different TV shows to different viewer profiles and improve their rating systems or targeted advertising. So their job is not, they don't have a feedback in terms of what is the best way to do. They have to come up with the best way to do it. They have to come up with what is the most efficient way to profile different viewers in order to make it easier for them to target them. And they will have to evaluate the performance of their own classification. They have to collect feedback, and they would even have to define what might be the best feedback in those cases. So those are very rudimentary problems for the TV industry back in 100 years ago. And I think another good example, intuitive example about unsupervised learning, which may not be exactly supervised learning, but it's quite intuitive to think in that way, is the constellation problem. When the let's see, when we try to understand the outer space, where do we start? We see all the stars. Some of them are not even stars, some of them are planets, but they are close to us. How to understand them? You need a kind of a map system to profile them. So based on our perspective, you kind of group stars together, and they you give it a name, and hopefully it's a shape that we can recognize. So I think that's how constellations are born. It's just trying to help humans better remember things, or better deal with or understand an unknowable world, and try to come up with sort of like shortcuts. But these are easier to understand and easier to remember symbols. And how do you do that? You typically group things together that are close to each other, and constellation is a way to do that. So constellation is not exactly a clustering problem, but the process kind of mimic that concept of clustering or segmentation. All right, for reinforcement learning, it's the training of a robot to do a particular job well. For that, you cannot use supervised learning, because you are creating a new actor. Before the creation of the actor, the machine, there's no data available, so there's no feedback. It's not unsupervised learning either. There is no available data even. So you have to create a machine to collect the data. So this is a targeted training of machines to perform a particular job. You need to define the reward and penalty to help the machine navigate the action space and try to learn and acquire new actions or new solutions to perform the job to a better extent. So that's reinforcement learning. It's a kind of a very coarse summary. I don't know much more details about reinforcement learning, but I think that is basically the process where AlphaGo is able to win humans, is to simulate a lot of opponents and be able to compete with itself. And over time, it learns creative tricks in beating opponents over and over. And after cumulative training, the algorithm is able to beat majority of the opponents. So that's part of the reinforcement learning. So after talking about the three categories, I have a question for you. Where do you think text mining would fit in the picture? Text mining is basically, trying to better understand a bunch of texts and a bunch of documents. So that's as far as I can say. Where do you think text mining would fit in the three categories? Let's do another breakout room and think about it. I will stop the share screen here. And I think that is pretty much, I have only a few more slides. Okay, now let's do a quick breakout room. Let's do this, okay.
I would say maybe supervised learning.
That's where I was initially going to go with.
Yeah, me too.
I was going to say unsupervised discovering patterns. I don't know. I really don't know. I'm just guessing.
So what exactly is text mining?
Yeah, I don't know what that is. Don't know what that is.
Good question. So think about leveraging machines to do the things that you do with texts. You want to replace yourself. I mean, nobody wants to replace himself with machines. But anyway, you want to make your life easier in processing the documents so that you can do the most advanced things and let the machines do the easier things. Such as putting the documents together. I have 100 documents on my desktop. It's so messy. I want to clean them. I don't have the time. So help me, machine, classify them and put them into categories, and so that it's not as messy. And same thing as with organizing your iPhone apps. So that's one example. That's not all of it, but some of it.
Well, with that kind of example, sorry, go ahead.
No, go ahead.
I was going to say, with that kind of an example, I would think that would be unsupervised, because you're like, here's what I want you to do. Now just go take care of it.
Yeah.
Is it? Is that the answer?
Well, it's more of an open-ended question. Now, so you found one. What about the other tasks that you can? What else can you ask a machine to do? Possibly translation or text mining. Some of the text mining is overlapping with the natural language processing. So translations, machine translations, or bots, dialogues. You ask a question, machine will try to answer the question. So that's part of the text mining as well.
I was going to ask, how is text mining different from NLP? It sounds like the same thing.
Yeah, it's overlapping. NLP deals a little bit more with the interaction side, but text mining is mostly dealing with assuming that the text data is recorded instead of interacting and being live interaction with humans, assuming that you have all the data stored inside the database. Think about a healthcare EHR system where you have all the patient's data and doctor's notes. And what can you do with those data?
That's NLP as well. Like, I've never seen text mining applied in. I've always heard it called NLP and never text mining.
Yeah, a problem can be that there's 1 minute left. A problem can be that a lot of times in hospitals, when they collect your information, they are all collecting the basic information. But doctors will really benefit if they can hear other doctors' opinions about the same patient. But those doctors that have seen this patient don't have the opportunity to record too much information for other doctors to see. So, but one thing that may be beneficial is that the previous doctors record their thoughts in a text, and then later future doctors can see them. But reading those notes may require time, and putting in those notes may require time. So once the thoughts are recorded in the database, an algorithm may be able to analyze, maybe able to analyze those text information and try to sort of summarize or highlight something from the previous doctor's notes and to enlighten the next doctor. I don't know. This is one thing that you can leverage the machine to do, to extract information from the texts. So think about that example, and I hope you had some discussion. So what are your thoughts?
But it's unsupervised learning.
Yes.
Yes, because it has a pattern. It's just like text mining is just like we're looking for some pattern, and we can say it's kind of unsupervised.
Yeah, let's see. The majority, I would say, the majority of the text mining problems are unsupervised. Think about the problem that Google faced. In 20 years ago, Google has, we have the internet, and Google has some algorithm to work for them. But Google's problem is try to match your search with the document. Based on a few keywords, Google tries to rank the documents in the order of importance and relevance. Google doesn't know the best way. Google doesn't have a sort of a human judged score of all the documents available online to provide feedback for them to train an algorithm to predict the future, the new documents. Google doesn't have those. All Google has is a text inside each of the document. So what can they do? They have to leverage the meanings of those words and texts inside each of the article, and try to rank and try to quantify and rank the relevance of each document given a new keyword, right? So they don't have supervision, they don't have feedback from human experts in terms of a specific pathway to judge the ranking of the documents. What they can do is to come up with some kind of algorithm to automatically quantify the texts in the document based on a keyword. So that is considered unsupervised learning. But with supervised learning more mature, you definitely can apply supervised learning to text mining. For instance, in sentiment analysis of Twitter tweets, given a massive data set, 1 million Twitter tweets, and if you ask humans to label 1,000 of them, so humans read 1,000 tweets. For each of the tweet, human will provide a label. It's positive, it's negative. Something that is positive is, Trump is so great, and something negative, Trump is a piece of shit. Excuse the language, but so humans provide the label, and then machine try to analyze the words in the tweet, and try to sometimes tag the words, sometimes analyze the relationships or co-occurrences of some of the words to come up with the algorithm to quantify the sentiment of a tweet. So given these labeled data and the algorithm for new tweets, the algorithm is able to predict the sentiment that is close enough to human judgment. Given enough training, the algorithm can be very accurate. So that is a supervised learning, right? But NLP, we talked about NLP in one of the group. In human-computer interaction, computers have to collect the data and then try to answer the question of the human in the best way, in a way that makes best sense. I think this part requires some of the reinforcement training to train the machine to better understand not only humans in general, but this human. Machines interact with this human particularly, especially with smart homes. So the machine can be customized to serve a particular host in a better way over time. The machine can learn reward and punishment. It can collect feedback from this host and then improve or customize the algorithm over time by using reinforcement learning. So the answer is it's everything, but with different applications, it's one of them. Does that make sense? Great. So I'll just spend a few minutes to finish today's slides before the data science warm-up so that we can get all the conceptual slides behind us. And then next week we can deal with Python, which will be very exciting. Because data mining and machine learning or artificial intelligence projects are complex, there needs to be a standard process to do them. There are a couple examples, but CRISP-DM is one of them that I emphasize all the time because this model is both intuitive and comprehensive enough and also makes the best sense. And more particularly, it's a better model to guide business projects than other computing projects. You can, this is a highlight. Wait, let me see. I don't think I shared the screen. Let's do that. So on the screen, it's the highlight of the 6 phases. The phases are cyclical. They can go back and forth in some of the phases to revise the project. So the project can be adapted. We'll skip the breakout room here. For more details, you can read in the book. The book explains things pretty well, the DKD book. And the PML book also mentioned this process, the roadmap. And if you compare them, they look remarkably similar, mostly in these 4 phases. Pre-processing is quite similar to data preparation phase. Learning is mostly building the model, so that's the modeling phase. Evaluation even have the same name. And the last one is making a prediction, which is implementation phase or deployment phase. So all of these 4 overlap, but the PML roadmap doesn't have the first 2 phases, but guess what? In business projects, a lot of times these 2 phases, but also sometimes including the 3rd phase, the first 3 phases consume the majority of the time of those projects because, data in business disciplines are much, much messier than the data in computing sciences or engineering sciences. Data in businesses are not prepared so far for data mining or machine learning projects. The collection of the data are not to support data mining per se. So those data are very messy, very dirty, requires a lot of time and even time to understand them. That's the reality that businesses are facing in terms of applying the machine learning. So just be aware of that. Not that the pathway in PML is not good, but they are talking mostly to the computing folks. We are talking about the business folks. Basic terminologies here. I hope that if you're data savvy, you're familiar with most of these. Because our time is limited, in future classes, I won't repeat all of the terminologies. When when I say variable, I mean a column, mostly in a two-way table. I mean a feature of the object or subject that is the focus of the analysis, or that's a field. And basically that is referring to the import variable, or the attribute. So all of these are synonymous to each other. We will deal with the loss function because we want to unfold the process of the machine's learning from the data. So we will construct the loss function and the gradient descent. I think that's all the conceptual things. That's it for today. Let's call it a day. Any questions before we leave? Or feel free to use the rest of the time as questions, or feel free to leave. Stay if you have questions. Stay if you want to hear other people's questions. Leave to mind your own business. Good. I'll see you next week.
I have a 3.6 Python from last semester. Is that the same one I'm going to be using? I think this need to update or something. Or
you have 3.7, right?
I have 3.6 32-bit. That's what I have right now.
3.6 should be good. You don't have to update the Python.
Okay.
Only update the packages.
Do I need to update the packages? Okay.
Yeah.
Is that on the slides to do that, or do I need
if you remember from last semester, it's the first module, but here it's also in the Blackboard. In the Blackboard, there are the very top of the tutorial page. You have the install Python tutorial. I think it's a part 2. Teaches you how to update a package or install the package.
Okay.
Yeah.
All right, I'll look at that.
Yes.
You?
Yeah. Any other questions?
I have the same question. Yes, I have the same question. Mine is 3.8.2. Is that fine?
3.8. I think so.
Right.
I'm very confident that 3.6 and 7, you can install the Google TensorFlow.
I did actually. Yes, I did. Yes, I've downloaded, but because I have a 3.8, it still show up.
So you can't use TensorFlow?
Yes.
Okay, then in that case, I would suggest you, if you don't have important things already working on using Python 3.8, I would suggest that you uninstall Python 3.8 and reinstall the version that I recommend. Yeah.
Right.
Mm-hmm. Any other questions?
Thank you.
Yeah, my pleasure. Any other questions?
I have a personal question, so I'm going to wait for everybody else to leave.
I had a personal question too. I wanted to talk more about what we were talking about in our group, and how those two disciplines of AI are similar and different, and like something outside of class time.
Okay, we can answer that now. If you don't want the privacy, no,
it's fine. If you don't mind, we can talk about it right now. If you don't mind.
Your question is about your question is about machine learning in different disciplines. Is that
how is the same thing? How is NLP and text mining different? Because like it's the same thing from how I've always understood it. A lot of the things you talked about, text mining, is the same exact thing as NLP, and the only difference you seem to make was that NLP is interactive, but I think it analyzes text as well. I don't think it analyzes voice.
No. So in terms of NLP and text mining and things, be aware that these terms refer to very specific technologies and algorithms. So this is different from other disciplines such as laws or history. Don't take the abstract names, don't hold on to them, but more specifically, you need, focus on a specific algorithm or technologies. So when we talk about, my short answer is, when we talk about unsupervised learning, it's mostly going to be related to text mining. When we talk about the specific techniques and specific algorithms, you have a better feel of what it means, and go from there. We don't have to be obsessed with those names, because at the very high level, it's not very meaningful to talk about what they are, and because I hope that you have your first-hand experience about those algorithms, then you have your own definition of what this is and what that is. When you deal with it, when you talk about those with other people, it becomes more personal and meaningful with you. That's so cute. That's so cute. And I have the youngest audience, a youngest student here, which is the Stephen's son, or maybe the other. Stephen's son. Looks like 6 months old. 6 months old. This is the record. All right, Corinne, if you want to share your question, go ahead. Otherwise, we can wait.
Oh, it's personal. It's about certificates and my course schedule and yada yada.
Yeah.
Hi, Professor Ma.
Okay.
I have a question about our course timeline.
Yeah.
So I'm looking at the course timeline, and I'm wondering that and is today's class lecture 1?
Yes.
So are we supposed to do lecture 2 for our next class?
Yes. Those activities that are before lecture 2.
Okay.
So that's your best expectation. It's fine if you skip one of the, but it's better if you prepare them before the class.
Yeah. So before our next class, are we supposed to do the reading, like the second part of the required readings?
Yeah. Let me see. So lecture 2, before lecture 2, in terms of the reading, it's the DKD second chapter and third chapter and relevant sections. And the PML is the optional, but it's if you read them, it'll be helpful. Yeah.
Okay. And we're also supposed to watch the prep video 1, right?
Yeah. Yeah.
Okay.
Yeah.
Gotcha.
So that's how to read the map. And most importantly, everybody complete the screening test. It doesn't count for what the grades, but it's helpful for me to know that everybody has installed Python. And even after today, as you start reading the books, you can start doing homework 1. Because homework 1 is overlapped with the time.
And I also have another question about installing Python on my Mac. So I found that Mac already have a Python 2 installed.
Right. And same thing with Windows. Windows also has Python 2, but that would not be adequate. When you install Python 3, it will not interfere. Python 2 will not interfere with your Python 3. After your Python 3 installation, your Python 3 will be the primary version of Python that the system recognizes. So whenever you type keyword, Python or pip, the terminal will recognize it. So there's no concern. But some things are different in Mac. For instance, the Jupyter Notebook workspace directory is different in Mac. You don't need to. There's no hidden, directory configuration file you need to deal with. Hopefully, hopefully you find out your way through your Mac system and have no problem. But if you have, questions, how to work with Jupyter, let me know.
Okay, thank you.
Yeah. Anything else?
Dr. Ma, what is the difference between the prescriptive analytics and the predictive analytics?
Descriptive and predictive, right?
Yes.
Somehow I have trouble finding who is talking.
Me, Sahityam.
Oh yeah. Sometimes the tile moves up whenever somebody talks, but I don't seem to see that happen here. So it's a great question. In analytics, business folks like to talk about 3 types of analytics: descriptive, predictive, and prescriptive.
Yeah.
3 tiers of, or it's sort of like a timeline, or not time, life cycle of analytics. I think it's beneficial to talk a little bit about the purpose of analytics. In mostly in business contexts. We try to leverage machines and machine learning, these computing technologies to help with our business processes and business operations. With data, the first thing that you can do and also have to do is to understand the data, understand what's going on inside the data, and start to see a little bit of a relationship between what's happening that can be revealed from the data. That's mostly using the exploratory data analysis, visualizations, and simple reports, maybe dashboard, and correlations to summarize what's going on in the data. That is considered descriptive, because whatever found there is the initial sign of what may be going on at a deeper level, but you can't really draw too many conclusions from those analyses. Those are surface level scrubbing of the data analysis. Now then you go to the next level, you start building more rigorous predictive models, and to feed the model with adequate amount of data. Then the conclusion, the findings from predictive models, if the design is healthy, then the results can be used to guide businesses and decisions. That is considered the predictive analytics. However, predictive analytics don't tell you why. It just tells you what to do. And if you do this, bear this amount of risk, because there's error there. There's never a perfect model to predict future. There's no free lunch. But many times, machine learning can beat human experts even. So a lot of them are useful, but they don't tell you why. To know why and to provide suggestions and guidelines to sometimes prevent some of the outcomes, or to lead outcomes toward more desirable direction, that is prescriptive. Think about this concept in medicine context, in healthcare context. In healthcare, by looking at the lab tests, you can read the result. You can sort of tell what's going on. You can summarize the health state of the person. That's descriptive. You can, based on the lab reports, you can predict what might be happening next in the next week. Maybe in the ICU, based on the blood test, based on pressure, based on heartbeat. Those reports, you can predict the life expectancy of a person severely ill in the ICU. That's predictive, but that doesn't get you, why this is happening. To know why this is happening, you need to have more information and use medical knowledge to diagnose is it the bacteria that's causing the problem? Is it the virus? What is it? That requires expertise, knowledge in terms of the cause effect. So I hope that answer
Yes.
is helpful.
So forecasting is a prescriptive analytics, or?
Forecasting is predictive.
Okay. Okay. Yeah. Thank you.
Yeah, my pleasure. And any other questions?
Yeah, I got a question. It's not about this course. It's about your MIS, the predictive analytics.
Mm-hmm.
So,
are you signed up on that course as well?
Yeah, I enrolled in that class.
Yeah.
So basically, we need a license for SAS, right?
Yeah.
And I sent the email to the to the IT department, but they never get back to me.
I think they might be just overwhelmed, not because of the SAS request, but just because at the beginning of the semester, we have the KuberNet tech migration that just finished over the summer. Students have lots of different problems with the software. So they usually, I think in the past semesters, it usually take a day for them to reply. Unless they have a renewal problem in terms of the SaaS license at the enterprise level. If they have not renewed the license with SaaS, then there's no way they can provide that. I'm hoping that that won't happen. They renew every year. It hasn't been a problem yet. This year is different. Universities are cutting the expenses. I don't know, and SaaS license is expensive. I don't know what happened. Maybe I can email them and find out. Assuming that they don't have that problem, then give it two more days. I think they will email you the license.
Okay, cool, got it. All right, thank you very much.
Sure.
Okay, yeah, that's all the questions I have. Thank you very much.
Yeah, have a great night.
All right, have a good night.
Yeah.
Bye.